Welcome PM1 students. We thought it would be helpful for us to do a quick look at some of the past exam questions from June to October for the circular measure part of the course. So here's one from the June 1-1 paper. We've got a symmetrical metal plate. The plate is made by removing two identical pieces from the circular disc C. The boundary of the plate consists of two arcs PS and QR. PS and QR, right. And of the original circle, which is the centre C, and then there's two semicircles, which are PQ and RS of the diameters. Okay, that's helpful. The radius of the circle, well, centre C is 4. Okay. And we know that PQ and RS are also 4. We've got to show that the angle PCS is 2 pi over 3 radians. Okay, well, so probably first I'm going to think about this. Here I can draw a triangle, right? Sorry, I'm just freehand this on the computer, which is not so great. But I know that the radius is 4, so I know that's 4, and I know that's 4. But I also know that that's 4. So my first step is angle RCS must be equal to, it's an equilateral triangle, so pi over 3. Make sure you're working in radians here. So I know that. And I also know that this triangle here, so, and angle, what would we call that? PCQ equals pi over 3. Okay. We know that angle QCR equals angle PCS. Therefore, angle PCS equals, now, area of a circle, angles in the circle is 2 pi. Subtract 2 lots of pi over 3. And we're going to divide that by 2 because those two angles are equal. Now that gives us 4 pi over 3 over 2, which is 2 pi over 3. Oh, so that was quite easy, really. Now, find the exact perimeter of the plate. The exact perimeter of the plate. Okay, well, now that we know that, I guess you can, if you look at the perimeter, you've got, I guess, 2 of these, right? Whoops. And then you've got this here, and this here. Okay, so this bit here is going to be pi d. Yeah. So it's 2 pi r theta, right? So it's 2 pi radians times so that's the angle, that's a theta, and then we're going to times that by the radius, which would be for that one too, okay? Because this whole thing at the bottom is 4, so you've got 2 on each side, okay? So that's that bit there. So this should give us 4 pi, and the reason I'm saying both of those yellow bits add up to one whole circle, so that's that bit. And then when we think about this bit here, well, we've got 2 lots of them, and each one, so remember we're using r theta, right, for this. Now r is 4, and we know that theta for each of them is this bit here, isn't it? 2 pi over 3. And this will give us 16 pi over 3. And then if we add them all together, therefore P equals, now we can say, well, 4 pi is like 12 pi over 3, so it's 28 pi over 3 is an exact perimeter. Now the last bit is we've got to show that the area of the plate equals this thing here. Now this is tricky. Well, I think it's a bit tricky, more tricky. So let's just have a think about how we're going to do this. Okay. So if I draw those triangles again, maybe this will help me a little bit. And I'll just sketch the rest of that triangle, sorry, the rest of the circle, and then the triangle would be across like this. Okay. Okay. Now what I think we can say is the area equals big circle minus 2 half circles, the little ones, minus shaded region. Now I'm going to show you which that is in a minute. So the shaded region, somehow I've got to get rid of this bit here as well, because that's outside of the semicircles, but also it's not part of the circle. Okay, so what I'm going to say is the area of the big circle, pi r squared, so r is 4, so that should be 16 pi. Now the 2 half circles will be, well, we're just going to add them up as one, so each of them is got a radius of 2, doesn't it? So, right. So pi r squared, so it should be 4 pi. Now this is the bit that's tricky. Now, how are we going to get that? Well, I like to think of it as this bit here, this purple bit, is a sector. Okay, so a sector of a circle is half r squared theta, half 4 squared, and we know from here, I think that we found this was pi over 3, wasn't it? Because it's that bit. Then what we're going to do is we're going to take away the triangle, right? Which would be in here, this bit here, right? Oh, that bit, right? The triangle. And the triangle is half times AB, which is, they're both 4, and then times sine the angle. Now, when we chuck this together, we get 20 pi minus, in here we'll get 8 pi over 3. Take away, now what's sine pi over 3? This is one that we should memorize, isn't it? And obviously I haven't. I always forget this. Is it square root 3 over 2? Or what one? Hang on. Sine pi over 3. Square root 3 over 2. Yeah, square root 3 over 2. And then we're going to times that by... So, times 16 times 0.5. So, 4 square root 3, I think it should be. Oh, I made a little bit of a boo-boo there. That one there is actually meant to be 12 pi, isn't it? Because I should be subtracting that 4. So I've only done one of these, so this whole thing should be multiplied by 2, shouldn't it? Because I've only done one of the triangles. Okay, so we need it multiplied by 2. I was wondering why my answer that I did earlier was different. Okay, so that makes sense. So then we should have 12 pi, subtract 16 pi over 3, take away, that would be 8 plus 8 square root 3 when we multiply that up. Now, 12 pi, what do we say, that was a 36 pi, so this should be equals 20 pi over 3, plus 8 square root 3, which I think, is it what we're trying to find? That's what we're trying to find. Yeah, it is. So that would be my, I could bring this whole thing down here, couldn't I? Oh, wait a second. I could pop that down here. There we go. Okay, good. June. Oh, let's take a look at this. What have we got here? Ooh. So cross-section of 7 cylindrical pipes, okay, each radius, okay, that's helpful, held together by a thin rope which is wrapped tightly around the pipes. The centers of the 6 outer pipes are A, B, C, D, E and F, and points P and Q, okay, situated where the straight sections of rope meet the pipe with center A. Yeah, cool, okay, I've got to show that. Fine. Yeah, I kind of get the idea of this now. So, I can see straight away, and I'm sure you can as well, that if we just join this up like this, we should have a regular hexagon. And we're going to have a piece up here, we're going to have a piece here, a piece here, a piece here, a piece here. Whoops. Okay, there you go. Now, we know that angle FAB is, now if it's a regular hexagon, which it is, it should be 120 degrees, 120, which is 2 pi over 3. Okay? And I also know that angle QAB is pi over 2. And angle PAF is pi over 2. And therefore, angle PAQ is 2 pi, take away all of those things added together, 2 pi over 3 plus pi over 2 plus pi over 2 equals pi over 3. Find the length of rope. Okay, cool. So, okay, so if you look at these bits, I've got a straight bit here, 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 straight bit here. All those are the same, and they're the same as this bit here, which is 2 radiuses, isn't it? So 6 times, what did we say the radius? So 6 times 40. And then, of course, we've got all of these curved bits. And they've got the angle that we just found. Whoops. So it's 6 then. Now r theta is our arc length, so 6 times. Now r is 20 and theta is pi over 3. Now we add this all together. And what do we get? 240 plus 40 pi. And that's 3 significant figures. That. Now, we've got to find the area of the hexagon. A, B, C, D, E, F. Now, the area of the hexagon is like that, made up of 6 of those triangles. Okay, so what I'm trying to do now is find out what this triangle is, and I'm going to multiply it by 6. So 6 times half AB. Now in this case you can see that it's made up of 1 radius, 2 radius, 1 radius, 2 radius, 1 radius, 2 radius. So it's an equilateral triangle, as we suspect. We should know, shouldn't we? 20 is the radius, so it's actually not 20, it's 40. So 40 squared, and then the angle is pi over 3. And this will give us 40, so 3 times 40 squared, which is 4,800, and then sine pi over 3 is square root 3 over 2, so we could rewrite that as 2,400 square root 3. Alright, we'll pop that down here. So that's nice. Now, find the area of the complete region enclosed by the rope. Okay. So now we've got to figure out the rest of it. So what I'm going to just getting a messy diagram here. We need to find this area. Now these are, I hope you can see, rectangles. And even though I have not drawn them very nicely, they are rectangles. So those there's 6 of them, and you can see that they are 1 radius wide by 2 radiuses across. So 6 times 20 times 40. So that's those bits. Now what does that give us? So that's 4,800. And then the only other bits that we've got to worry about are these bits here, and we've got 6 of them. They are arcs, sectors, so 6 lots of half r squared theta, so half times 20 squared times, I think, what did we say they were? Pi over 3. And this will give us 3 times 400 times pi over 3. This is 400 pi, I think. Now, so we've got those bits, and then we've got our so it should be 4,800 plus 400 pi, plus 2,400 square root 3. Now, what does this give us? When we add it all together, and I get 10,200 to 3 significant figures. Alright, I hope that's helpful. Let's do one more. Here we have the diagram showing a circle, triangle, so triangle ABC. Angle's 90. Sector ABD is part of a circle center A. Okay, right. And the area of the sector. Okay, BAD in radians. BAD in radians. Okay, we'll make sure we do it in radians. BAD. Well, if we know what the sector area is, we know that half times r squared, which is this case 4, times theta equals 10. And therefore we can just rearrange. So theta is equal to 10 over 8, which is equal to 5 over 4, which is equal to 1.25. The perimeter of the shaded region. Now that we know what this is here, we can find out BC. So BC is, we're going to use tan, so tan 1.25 equals opposite, the unknown, over the adjacent, which we do know. So BC is equal to 4 tan 1.25. And DC equals AC minus 4. So let's find AC. So I'm going to use cosine. Cosine 1.25 equals adjacent over hypotenuse, and so AC is going to be 4 over cos 1.25, and now also arc. So therefore DC equals 4 over cosine 1.25 minus 4. Okay, so there's that bit. And then the final bit is arc BD, and that's r theta. So r is 4 times 1.25. Now we're just going to sum all of those to get our total. So total equals 4 tan 1.25 plus 4 over cos 1.25 minus 4 plus 4 times 1.25. Let me just chuck this on my calculator. 4 tan 1.25 plus 4 over cos 1.25 minus 4 plus 4 times 1.25. So for this I'm getting 25.7 to 3 significant figures. Okay, well I think I'm going to leave that one there for now. I might come back to the October ones at a later date. Hope this has been helpful. Let me know if you do have any questions. Take care.